Are you gonna be okay? Go home, camera. You're drunk. All right. Let's see. There we go. All right. So whatever you guys wish to discuss, if you wish to discuss nothing, this is a very quick class. Chris?
Can we go over B on the practice? 1B or 1B?
1B? Oh, okay, right. So what does a negative power mean? This one here, right? Whatever a negative power is on is going to do what? Four-letter word starts with F. You could say in this company. Flip. So what is being raised to negative power? 3 over 5. So it's going to become
5 over 3.
Yeah, it's almost too nice to believe, but that's the idea of a negative power. Now, there's still a square up there. I haven't done that one yet. So what does a negative power mean? It just means flip. That's all it means. So watch, and so what's that?
25 over 9.
Yeah, 25 over 9. So watch this. What's 3 squared?
9.
9. So what's 3 to the negative 2?
9.
What's a negative power mean? Flip. There's no way that 3 squared and 3 to the negative 2 can be the same thing. Right? It wouldn't make any sense for them to equal the same number. But they don't. Negative power means flip. So whatever this is, the negative power would just be 1 over that thing. Or that thing flipped. Right? How are we doing? Is that? Yes, yes? Maybe? A little bit? Okay. Yes?
Can we do 2F on the practice test? 2F, yeah.
Who in the world? We got a loud talker. Must be the next 8 weeks of starting. We got Mr. Loud Talk over there. Shit. All right. 2F?
2F, yeah.
Oh, this is, I
had a little tricky.
what happened?
Well, I got confused at the end of, I was distributing, but then, I erased it now because.
Shit. Have you guys tried 2F yet on the practice
I knew it
test?
wasn't right.
If you haven't tried it, do it now. Do it right now. I love 2F.
Try it again?
Try it again.
Okay.
You never know. Oh. Here. If you already tried this one, just hang out. Stare at your favorite wall. Those two Jesus. So it's an interesting idea. Jesus looks down and says, I don't do math. Oh, shit. It's too bad for you. You gotta pray too different. So what's going on with this one?
It's all canceling each other.
Yeah, because do you notice little dude, big dude? 1x, the other 2x. 1 3y, the other 2 3y's. 3xy in the middle, opposite sign. It's a difference of cubes factored. So it makes sense when I multiply this shit out. A lot of things are going to cancel, right? I do. I just haven't given them out yet because I like to force people to stay. Or, trick people to stay. I haven't. I'll give them out later. So what do you get? So let's see, we get what? X cubed.
Minus 2 squared y. X minus y squared. Plus 2 squared y. Minus 27
This cancels exactly how it's supposed to. So it is really nice to every now and again see that in action to reconfirm that this is, of course, the way this guy kills the shit. This is the way we factor this.
It's a sum of two cubes, right?
Yeah.
And that's okay because it's cubes, right? You
Yeah.
said squares, it can't be a sum?
Squares are very uptight.
Oh.
Cubes are like, you're negative? Stay negative. Squares are like, you're negative? No, it can't be. Oh my God. Yeah. I don't know. That's the way I look at it.
Okay.
Sort of like there's a function you learn in trigonometry, and I call it the asshole function. So, because it's just an asshole. So, someday you'll get there.
Oh,
Yes.
another one. 1J.
Oh yeah. Okay. Now, on the actual test, I am going to ask you to use long division on a problem, and then a separate problem is going to ask you to use synthetic. You have to be able to do both.
Okay.
This one is just sitting there. You can use whatever you want to.
Synthetic is where you put it in a box and
Yes.
you just put the numbers without the variables.
So let's do this one both ways.
Okay.
So long division, everybody's favorite. All right, so x times what is x squared? X. Then you
Switch the sign.
change the signs. Negative 2x. X times what is negative 2x? Negative 2. Change the signs. So you get plus 1 over x minus 2. Okay, so that's what it is, long division.
Can you just go back to the first step?
Wait.
Alright, we'll do that again.
Sorry.
We'll do it live. We'll do it again. Ah. I love how you're all just sitting there like, he's going too fast. I wish there was a way I could tell him to split it. Oh, yeah. Alright. So how does it work with numbers? You put up here the thing that when you multiply with this becomes this. So what times x is x squared? X. So then what's the next thing you do? You multiply that thing you just wrote by what this is. X times x.
X.
X times negative 2.
Negative. Negative.
That's what it is. I haven't changed any signs yet. Don't get ahead of me. X times this, bam. X times this, bam. Then you
Okay. Change the
subtract, so change the signs.
sign. That's right.
Negative 2x, bring down the 5. X times what is negative 2x? That's right, kids. Negative 2. Negative 2 times x.
Negative 2x.
Negative 2 times negative 2.
Negative 4.
Positive 4.
Positive 4.
Then you
Switch
Change the
sign.
sign.
change the signs. Okay. Is that cool? Okay. And what would this look like using synthetic division? Since synthetic
2
one.
inside of it. I mean,
Yeah, 2 in
two
the
inside
penalty
of
box.
the little box.
1, negative 4, 5.
Beautiful. Why aren't there any zeros here? Because I'm not missing anybody, right? I don't miss them.
Bring down the 1.
Yeah, why we put a 2 there, by the way?
Because the sign flips.
Sign changes there instead of changes every damn time, right? We just change it once at the beginning. That makes sense. If the 1 comes down, I like it.
2. Negative 8.
Add,
Oh, negative 6.
multiply,
Oh my god.
add. Right? And you can see, negative 4, 2, negative 4, 2, right there. 5 minus 4, 1. 5 minus 4, 1. You can see how it captures the most important parts of the process. And here's where people get a little stuck sometimes. How do you interpret the answer? It started off as x squared, so what's this the coefficient of?
X squared.
X.
X. Because what did I do? I divided something x squared by something x. So doesn't that kill an x? Yeah, just lose an x. So if this was a cube, the answer would start with squared.
So it's x minus 2.
Does that make sense? So it'll be x minus 2.
Plus 1 over x minus 2.
Yeah, that last number is always the remainder. Thankfully, we got the same answer. Or else we would have had to throw all the math out and spent the rest of the semester at a bar or something. It's too bad for you guys who worked. Right? We were that close. Okay.
Should we just do I then? Or actually H looks hard.
Well, I is a good one because people have really made this problem really weird. So I kind of, sort of, that's kind of neat. Doesn't take much for me to go. You stay there. So, let me ask you this. This is going to look unrelated for a second, and I don't care. Can you simplify that? I mean, you've seen this before this class.
Yes.
Yeah.
How do you simplify that?
Divide by
Take
two.
out 2.
Yeah, you could take a 2 out, or you can just... Now, what's wrong with... What did the person do wrong here? Get out of there. Right answer. I can't even write the wrong answer.
We didn't divide the exponent.
I divide by 2.
But you did
Right?
divide
4
by
divided by
two.
2 is 2.
Yeah, but they
You
forgot.
didn't get the 8.
Yeah, so what's being divided by 2? 4 is being divided by 2. So this is shit. 4 is being divided by 2, and 8x is being divided by 2. So that's all. When the bottom is a single term, you rewrite it into several little problems. You don't have to do long division for that shit. So for this one, for 1I, I would first rewrite it as 24c squared d cubed over 6 cd squared minus 12 cd over 6 cd squared. Do you see what I'm doing? I'm just breaking it up. Each of those things on top are being divided by that. Let me write it like that, and then I can just reduce each piece.
So you don't take out the GCF first.
No,
That's right.
because then you're not really dividing all the way.
Well, yeah, I know. Because then I did it one more time.
And now you just reduce each piece. So you take one big gross problem, make it 3 little tiny nice problems. Okay, maybe. So there are several problems in the homework where a lot of people, and I don't blame you that much, but still, look at examples in the book. You were doing long division for these, you didn't, oh my God, just do this. You only need long division if the bottom is more than one term, like x plus 2 or something. Then you need long division. Okay. Anything else? Yes?
1G.
Oh, okay. What is something to the 0 power?
1.
I shouldn't leave this up here, it's going to freak me out. Oh no! Oh God. Why is it still here? Go away. Oh, it's so freaky. Go away. Alright, Jeebus. It's like a hidden message in there or something. Alright, what was it? Oh. What is something to the 0 power? 1. So watch. If I multiply this by 2, I better multiply this by 2, right? I mean, so why is 2x to the 0 2, not 1? Because what's being raised to the 0 power?
The X.
Just the x. What's this, though? 1. Because anything to the 0 power is 1. And then I still have somebody that would say, well, then why is that not 1? Because 2 is not being raised to the 0 power. There's nothing that's going to make it become 1. It's just 2. You guys see the difference there? The classic difference is like between these two things. Those are different. The parentheses let the exponent go further than it normally would. What's this one?
4.
Positive 4. What's this one? Yeah, what's 2 squared? 4. 4. Put a negative on it. See, the square doesn't affect the negative. There's only one negative. Here, there's two negatives. That's why they kill each other. All right, what's it got to do with this one? Well, here the 0 can get to both and kind of kill both of them, make them both 1. There, the 0 can only get to the x, so it's 2 times 1, 2. So that problem's got a little bit of everything, right? What was it? 5, m0.
Minus, in parentheses, 2.
Yeah, there you go. So it's got both things going on, right? So what's this one?
5 times 1 minus.
5 times 1. 11. Because m to the 0 is 1. 5 is 5. Ooh. Minus 1, yeah. And then just do that the right order, and you're okay. Special place in my heart for the person that does this. You multiply, then you subtract, right? So that's just 5 minus 1 is just 4. Shabbat.
Can we just move over to H then?
Yeah, okay. What is the big thing about part H?
Reducing.
Okay, reducing.
And moving the variable.
There you go. Moving the ones that have
More.
negative powers. Because the negative power is what allows it to move. That's the way I teach it. Some of my colleagues teach it a different way. And that works. Sorry. Like they watch this. All right. Let me watch what Jeff's doing. All right. So yeah, the numbers, again, what would you tell the person that writes this down on the next step? Can you see what mistake they made?
They subtracted.
They subtracted. Does it say they subtract? No. But what would I subtract? I would like subtract powers, right? Powers are not numbers. They don't work the same. These are numbers. These are powers. They have different processes, right? Never in the world has 55 divided by 15 been 40. What the shit? So just, that's that problem. Easy problem. What goes into both?
5.
5. I like it. So what do you get?
11 equals 3.
Now what am I going to move for the variables? Yeah, these two A's are going to go up. How many A's total am I going to have now?
7.
7. You guys see that? That is a quick, easy way to do that. I'm not going to do 5 minus 2. I would actually do 5 minus negative 2, right? Because I subtract power. So why do all that negative shit? And I can just move them and make them not negative anymore. So don't make negative mistakes. What else is going to move?
The 3 up.
Both the B's want to move, right? They don't. Neither one likes it where they are. Let me just write this down. And what happens here? How many C's would be left?
C10.
No. How many C's cancel?
There's C4 at the bottom.
There you go. How many C's cancel? 3. How many C's are left? 4. Where?
Bottom.
There. All right. And then the last thing you have to do is just, what would I do with the B's?
B1 on top.
Good. And then just a little C4 on the bottom. Just to
So
make
it
things
doesn't
interesting.
matter if it's on the top or bottom, if it has a negative power, it wants to move to the opposite side.
Exactly. Yes. Okay. I mean, we're at the beginning of your question, but now your total question makes sense. No matter where that shit it is, if it's got a negative power, it wants to be on the other side.
And then in the case of the C's, you just...
Neither one of them were negative.
So where's the remainder going to be on the...
But I want you to... Now watch. What do you do with powers when you divide? You're supposed to subtract, right? What's 3 minus 7?
4. Oh, wait.
Negative 4. And what do you with C negative 4? It wants to flip down. So why do all that shit? 3 C's cancel. 4 left. Where on the bottom? Done. No negatives have to come in. I want you to realize, it doesn't mean that this way of looking at things is wrong. It just means there's a better way to look at this problem. Nothing wrong if you do this. It's just better to look at it like this. It's just quicker. You don't make as many negative mistakes.
And you can just move that negative 3 from the B up to make a positive 1, right? Rather than flipping both.
Yeah, you're right. You don't have to flip both. But I just got into a flip
Okay.
frenzy. Sorry. Correct myself up. Correct somebody up. My eyes getting a little bit.
Okay.
Yes.
2G.
Oh, that's one I almost did earlier. 2G. Oh! So the biggest mistake on 2G is somebody will do this. Okay, that's not right. How do you official? Huh?
How do you even get that?
All right. So the mistake somebody would make to get that is they cube the x and they cube the 4. That's not what this is saying to do at all. How do you cube something?
Write it 3 times.
Write it 3 times. Now, just so you realize, I mean, help me out. What is 5 minus 4 cubed? Please do this the smart way. What's 5 minus 4 cubed? What's 5 minus 4?
3? I mean, is the answer 3? 1, but it's 3 times, so what's
1
the real
to the
answer?
third is 1 times 1 times
okay,
1.
you're right.
Yeah. So now plus. I'm with you. Is everybody cool with that? So if you thought the answer was supposed to be 5 cubed minus 4 cubed, that's 125 minus 64. You're getting 1 out of that shit. We know the answer is 1. So really, exponents cannot distribute across minus or plus because they're based on multiplication, not frickin' addition, subtraction. That's why you have to do it this way to get the right answer. Don't say, well, that's quicker, Jeff. Yeah, that's wrong. Right? Obviously, it's wrong. I'm not going to get 1 here. And I know the answer is supposed to be 1, so that must be wrong. And now, how do you do this? Well, tell me this. I have a special place in my heart for a lot of people. I've said that a lot. But the people that try to do all this at once, can you multiply 2 times 6 times 5 all at once? No, you can't. How do you do 2 times 6 times 5? Sure. And then times 5, right? Or I would do 2 times 5 make 10, times 6 is 60. Either way. Right? But you got to do 2, and then you bring the last one in. So how do you do this? You multiply these 2. And then you bring the last one in. So how do I multiply these 2?
X squared.
Yeah, x squared. Minus 4x, so minus 8x. Plus 16. And then you multiply this in. Same way you would do with numbers. You notice I keep making that point? Variables are numbers. They must act the same as numbers then because they are numbers. I know, I get a little excited. Sorry.
Just like, looking at the x minus 4 cubed, knowing that it's a difference of cubes, it should look like that, right, when you multiply it out?
It's not a difference of cubes. Definitely not. It's a difference that's being cubed. And I know that sounds like semantics. A difference of cubes would be something cubed minus something else cubed. That's a difference of cubes. Yeah. So be careful.
When we get to that point, it's gonna look like problem number F, basically.
No.
And we just stop there.
No. I mean, no. You do the same work. You keep going.
Oh, we have to multiply that out.
But nothing's going to cancel.
Yeah.
Because it's not a difference of cubes. Yeah. Nothing's going to cancel. You're going to have some like terms, but nothing's going to cancel. Because what's wrong here, if this is x and 4, and this is x squared 16, what should be in the middle? 4x, not 8x. So it's not a cube. So it's not going to cancel shit out. The middle dude, we got the wrong dude. We wanted the wolf, and we got the crane or something. Wrong guy. Doesn't really do the blood in the brains. I'm thinking about Kung Fu Panda. Crane style.
I think I said like the sheep or something.
I don't know. I couldn't think that quickly. Okay. Anything else?
Yes.
Yes.
Just
Chapter 6G on the back.
Oh, okay. that one really, really quickly, hopefully really quickly. You think there's a trick to it, I know, but no. The only way this is going to work is if you can find two numbers that do what? Add to be negative 45. And multiply to be 2. What's the only numbers that multiply by 2? 1 and 2. Do they make negative 45? No. So it's prime, right?
Okay.
Yeah. Now here's a really... Alright, let me see if you guys can handle this. Can anybody tell me what I can put here so this will work?
3.
Yes! Because 2 and 1 add to be 3, or negative 3. Those are the only two numbers. The last number is a 2 and the first one's a 1. The only two numbers in the middle that'll work are 3 and negative 3. That's kind of like a next level problem where it tells you to rearrange the way you think about things. I love those kind of problems. They could show up on like a bonus. I mean, something related to that.
Can we go over the different forms of polynomials?
Like monomial, binomial.
I mean, I guess.
What?
Yeah.
All right, so...
Sure.
All right. Is that a polynomial?
Yes.
Yes. What type?
Monomial.
Monomial. Good. I didn't put any pluses and minuses. One giant freaking term up there.
Oh, it's about
One big ass term. What's the degree of that term? This is a monomial. What's the degree?
11.
No.
13.
No.
18?
Maybe. I don't know. I didn't count them yet. 2, 3, 4, 5, 6, 7, 18. Yes. How do you get a degree of a term? You add up all the powers of all the variables. How many variables are there total? 18. 11 E's, a couple A's, a B, an X, a Y, a Z, and a W. Everybody see that? That's the idea of degree.
So
The degree of a term is how many total letters you see.
So what's the coefficient for the leading
Yeah,
coefficient?
you tell me. What's the leading coefficient?
14.
This is easy because it's only got one term.
14.
So it's 14. Yeah.
So a term is just something that's like a multiple but split up with subtraction.
Yes. So what separates terms, plus and minus? If there is no plus and minus in the whole string, it's one big ass term.
And
Now,
then the leading coefficient is just the number that starts that.
the number in front of the highest degree term. So let me change one thing in here, okay? So if I would have put this here, what you got, Jeff? I don't know. What type of polynomial is that?
Binomial.
Binomial. What's the degree?
18.
No.
58.
No. What's the degree of this term? 18. What's the degree of this term?
40.
40. What's the highest one you see?
40.
There you go. That's the degree of the whole thing. And what's the leading coefficient?
7?
7. That's the number in front of the highest degree term. So leading coefficient just means if you did put it in order by degree, what would the number be out front? That's literally what leading coefficient means. So yeah, if I put that guy first, 7 be out front. There you go.
If the variable that's the highest is, if the exponent that's the highest is just a variable, does that mean the coefficient's 1?
Beautiful. It's an understood one.
Okay.
I like that. I love that shit. I'm a man now. Or a woman now. Good point, Jeff.
Can you show us a problem where it equals 0? Like 7a?
Oh, yeah. Oh, thank God. All right. Real quick. So the idea behind number 7 in general, all of these on number 7, is if I can make something look like this. Now sometimes I'll give you a problem just like this. And people will start multiplying shit out. And I'm like, oh man, you're wasting time. You're going to mess yourself up. This is a nice problem. I've already factored it for you. Don't undo what I did for you. Right? This is not, it's equal to 0. It's factored. How do I get the answers?
solve for
Yes.
0.
This number times this number is 0, so either this number is 0 or this number is 0. Any other number that I put there, I can't do shit with. You guys understand that? 0 is the only number that makes something have to be 0. If there was a 4 there, these could actually almost be anything. If that was 8, that'd be a half. If that was 100, that'd be 1/25th. If there was a 4 there. There's an infinite number of ways to make 4. How do you make 0? One of them's got to be 0. Oh, that's the only time I know something for sure. Okay, so here you get x is 1, x is negative 5/4, blah, blah, blah. So if I start off something that's not factored, and what is it really that tells me I have to do this kind of thing? What part of that tells me? If I erased one piece of that, I wouldn't have to do this. Let me just tell you. What would you do then? Yeah, subtract 33, divide by negative 14, be done with the shit, right? So why does that guy mess everything up? Because now I can't get all my x stuff together. So we had to come up with a different way to do this, because it doesn't follow the old way. So I know part of your brain is always kind of like, why are we suddenly solving equations differently? Because we never had something where they weren't like terms before. Now we do. Oh, shit. So the first step is, how do you factor this thing? Is r equal to 0? Check. Yep, x and x.
11.
Oh, minus 3, 11.
So the x is
11.
11 or x is 3. So if you have a problem like B, C, and D, where it's not equal to 0, but there's x squared shit, you got to get it equal to 0.
So you just move everything?
Move whatever you need to over to make it equal to 0. Yep. And then factor what you get. I like part, what was it, Jeff? Part D? I'm sorry, C. Yeah, C is the one. C's got something interesting that happens. Maybe try that out real quick. 7C.
So why is that the answer?
No, I'm sorry. The answer, of course, would be, so either this is 0, right? Or this is 0. So x is 11, or x is 3. Is that cool?
But why? Because those are factors of 33? I'm confused at why you picked those numbers.
No. So we know it's 11 and 3 because they multiply with 33 and they add the negative 14.
Okay, so you factored
That first step is just factor.
Oh, okay.
And the equal 0 just kind of comes for the ride. And then we go, oh shit, it's equal to 0. Now we got to do extra. So the first step is just factor like always. Are you still going? Good little dude. I have no idea how much time. Oh, there we go. Okay. So what's going on with this one? What do you have to do first?
Equal it to 0?
Well, not really. Is there stuff I can do on one side or the other? What do I always do? I don't care what the equation looks like. What do I always do first? Simplify each side. Always. Right? That's just a step of equations. Now you're worried because there's x squares. I might have to eventually make it equal 0, but I don't even know right now if the x squares will survive the simplification step. So how do I do this?
4x. Oh, just write it twice, right?
Write it twice. So you have 4x squared minus 6x minus 6x minus 12x plus 9. So what happens on that side?
Oh, you add like terms? They
Yep.
cancel out.
They
the
cancel.
4x.
So the reason I would have to do this shit cancels. So then guess what? I don't do this shit. Now this is chapter 2. Now this is just solve, get x's on one side, numbers on the other side. I love that problem because I'm not suddenly changing how we solve every equation. I am adding a type of equation we can now solve. If that stuff goes away, I don't look at it like that anymore because the reason I would have went away. So now I'm going to add 12x, add 4 to the other side, get my x's together, get my numbers together. See? Maybe? No?
Where did you get 12x? Yes.
Oh, minus 6x minus 6x.
Oh.
I just put the two middle terms together. Yeah. You guys see that? And then, of course, x is 1. Yay. So if your x squared stuff cancels, the reason you would have to factor went away. Now you just solve it like always. Bless you.
Thank you.
Do you guys get that? Because that is a trap students fall into. They're like, well, this is how we solve equations now. No. This is a method to use when it's an equation that's worse than what we saw before. This one became a nice equation. Because the x squared shit canceled. Hopeful. Some of you guys that can't read at all. I feel okay about that. Okay. Now, 7a, 7b, 7d end up with x squared surviving. You have to get it equal to 0. Okay.
Review number 6A.
So 6a, why is that one not as bad as it could be?
There was a 1.
What was it, this here?
Yeah.
Yeah. Okay.
There's
There's a 1 here, right? So what's the only way to make x squared?
X and X.
X and x. So now I can focus all my attention on the numbers to work. They have to do what?
Multiply to 17.
Multiply to be 70.
And add to 7.
Add to 17.
And 7. So
Yes. Yeah. So 10 and 7. Multiply to be 70. Add to be 17. Cool. So it's just that ability to play with the numbers a bit. Because the letter part is set. X squared is x times x. Done. Numbers. Oh shit. Now I got to play with the numbers, get the ones that work right. But then I can just focus all my attention on that.
Can we do 6H?
Alright. Sorry, I was going to say, that's the one I won't do. No, I'll do 6H. I love 6H. Just say you love all the damn problems. I do. Make my Y more Y-ish. Okay. What form is this in? How many terms are there?
2.
2. So what form could it be in? Squares or cubes? And it's definitely squares because it can cut everything in easily. Right? This is exactly the conversation you have with yourself. Maybe not out loud. Inside voice in your head. So x to the 4th,
X squared.
x squared, x squared.
4, negative 4, y squared.
Plus, minus, yeah, and then 4y squared. 4y squared. I like it. Now, why am I not done? Why could I factor this one? Because it was a difference of squares. All right. This one is a difference of squares. This one can't do shit with. It just comes for the ride. Whee! This one I can break up again. X squared.
X minus 2.
Yeah. Minus plus 4y squared is 2y. 2y. You can make your house a little smaller. There you go. So when you start off with a higher degree on your factoring problem, you got to be careful. Maybe you can go further because you can be cut several times. I cut you. If it's squared, I can only cut it once. 4th power, I could maybe cut that a few times. 6th power, oh shit, Jeff, what are you doing to me? Yeah.
For I, would we try to pull out the GCF, or is it, since it's a sum of 2 squares, we just can't do it at all?
No. Careful. It's not a square. 8 is not a square. right? This one?
Yes. Yeah.
8 and 27, what kind of numbers are those?
Cubes.
Cubes. And I can cut that in thirds, I can cut that in thirds. No worries. Little dude, big dude, go to town. I like it.
How do you do 7b?
Oh, all right. So what's the major problem with how 7b is written that we can correct? What's it supposed to equal?
0.
Yeah, what tells me that? I have a higher power than 1 on one of my variables, so I know it's supposed to equal 0. Now, I love the people that just kind of do this. How the shit did that happen? How do you make that guy disappear? You gotta subtract it, dude. So it's better be minus. Now, how do I factor this? GCF. That is the thing that kills so many people. You just bypass a problem, you're like, it can't be done, and it's just until GCF. At least to start with. Right? So that's why I try to keep telling you, start with GCF. Try GCF first. So what comes out? X.
X squared minus 16.
And what's this? Squares. I like it. So X.
Plus 4x minus 4.
Whoops. Yeah. This is really weird. I'm looking at it completely sideways.
X equals either 4, -4, or 0.
Good. That's the one that people forget. If X is 0, the whole damn thing's 0, right? Yeah. 4, -4 is 0. Kick ass.
What? I don't get that part. I don't get the part.
All right, so what makes this 0?
Add the -4.
4.
So you
If
get
x
x equals 4.
If X is 4, so X is 4 makes that 0, makes the whole thing 0 then.
X -4?
-4. Now here's the really silly question. It's so silly that it seems hard. How do I make X 0? I make X 0. So 0 is another answer. If X is 0, don't I get 0 times who cares times who cares? Yeah. So if you have a factor of X, an answer will be 0. And what if I make X 0 in the original? What's this side? 0 cubed? 0. 16 times 0?
0.
Is it true?
Yes.
Hell yeah. In fact, we call that the trivial solution. If I get a value that makes everything 0, it trivially solves it. You have to remember that word. Don't worry about it. This is this is a really evil problem right here. And it shouldn't be. People try to do squares and all kind of weird shit. No, it's just take an X out. And then X is 0 or X is 9. Right? Because you forget about poor little GCF. You try to start attacking with all this stuff. No, don't bypass GCF. It's warm in here, right? Let me just work that up. Yes.
On 6H, how come you can't factor out that one?
So why was I able to do this? Since that's a negative, I'm allowed to have different signs, which allows the middle terms to cancel. Therefore, if it's positive, they'd have to be the same sign, the middle terms wouldn't cancel. And does it say I have a middle term? No. So the reason this does work is the same reason this don't. Hopeful. I know. You get to that point where everybody's like, I just don't want to miss questions.
6D.
6D? Yeah. So what we just say is the first step of every factory problem.
GCF.
So what's the GCF on that one?
2.
Yeah. When you take a 2 out, what do you get?
X squared. I mean cubed.
Plus 27.
I like that.
Just sum of two.
And now you got the sum of cubes. So GCF, you always do it first because maybe it's the only damn thing you can do. Or once you do it, you uncover something else. That's why it's always the first thing you try. Is that? And then of course it's little dude, big dude. I think that's the same thing that was on the front in reverse. I can't remember. I think there's a minus there, maybe. No, it's a plus. Yeah. So you actually have the answer to that in 2F. Right? Isn't that nice of me? But then you don't notice it, and then you find out later, and then you feel like, rah.
X cubed. Vice 2.
Oh, there were some problems in the homework that only one person asked me about that makes me a little bit worried. How would I factor this? It's not this problem. I'm building up to it. This is easy. No tricks. Nothing. Just how do you factor that?
X plus y.
Beautiful. Right? Why did I put in X there and then X there? Because there were 2 of them. Now, how would I factor this? Jeff's going to say something freaky like these are the same problem. These are the same problem, right? Something squared minus something else squared. So I put one of each, plus minus. All right, same damn thing here. What do I have 2 of? I have 2a plus b's, so I put 1a plus b there. Okay, Jeff, where are you from?
Plus y minus y.
Right, is that cool? Because that times that would be 2a plus b's. And then plus y minus y. Done. Yeah. And to be really honest, I wanted to show you that first. Here's the way it would look, possibly to start with. Let's see, what do you got, Jeff? I don't know, man, leave me alone. Come on. I'm always messing with myself. So what method do you need to use on this one and why? Grouping, why? 4 terms. I love it. So we normally group like this. Can you quickly see that's not going to get any damn where? So you got X's in it and it ain't got no X's in it. So I don't want you to get too freaked out. This doesn't happen all the time. But there were some problems in the homework that showed you grouping goes further than what we really looked at. I don't have to group 2 by 2 all the time. I group 3 by 1. Look at that guy. If I just cover that, can't you see how to factor that? What would it be?
X and 3 and 3.
Sure.
Negative, negative.
Negative, negative. Good. Got to multiply be positive, same sign, add to be negative, so both negative. What's a better way to write something times itself?
X minus 3 squared.
Doesn't that look just like that does now? So now I can do 1x minus 3, x minus 3, minus an m plus an m. Done. Next. So that just to kind of give you a taste that some of the forms of factoring you're learning, there's more flexibility to them depending on what the problem is. Right? I might give you something like that on a bonus. I don't want it to get too freakadelic. But I did give a couple in the homework just so you can see that that can happen. This is awkward.
Should 2a and 2b just distribute the negative? Okay, let's do 2b.
For 2b, yeah, distribute the negative, put your like terms together. I really feel bad for the person that looks at 2a and starts multiplying shit. I always get like about 20% of the class does that, and it's just wasting so much time. Can you imagine? Do you see how many things you have to distribute and how many combinations? And oh my God. But it says plus in the middle. Don't multiply when it says plus.
You just add them?
Just add, get your like terms together.
Oh.
Yeah. Part B, you just got to be careful, right? Like Jeff said, you got to distribute that negative, and then get your like terms together. But 2A and 2B, there's no foiling, thank God. Oh my God, that would be so evil for me to give that kind of problem. I'm not that evil yet.
2E.
Wait till I'm about retired, I'll probably be that evil. What's that?
2E.
2E is kind of funny because it's what's the operation there? What's the property I'm going to use?
Multiplication?
Distributive.
Yes.
Yeah, so you just take the 6mx cubed times 2m plus 6mx cubed times 5x squared. Yeah. Let me go ahead and give you guys the answer key. Maybe that'll...
You have an extra copy too?
Yeah. Give me a minute.
So you can't combine them with the second option. Yep.
Can I ask you? Okay, so for I, like, I got it the same as you, but I don't understand how you ended up with no problems.
You had 2 C's, so 1 cancels, so you got 1 left. 3 B's, 2 cancels, so 1 left.
Okay.
Yeah, yeah.
So you're still like.
Just reduce it, yeah, yeah. And I'm subtracting the exponents,
Okay.
reducing it.
It's the same one.